All right, hi, grade 12 IB chemistry students, SL and HL. This is John Mack. So I want to point out that there was something I forgot to finish up last time, and that was regards to the presentation I did on the infrared um, spectroscopy IR. So there was a few more problems that I did give you as an assignment, and I didn't really get to finish that with you. So I want to go to this um, last set of questions for the IR spectra activity. Okay. So if you remember, I gave you these problems. There's 5 of them with these diagrams. Now you can use the data tables from here or from your own IB data booklet, table 26 in the IB data booklet. And so these were the 5 problems I gave you last time. And I don't think I gave you the answers to this for this IR, okay? So before we come back to these 5 problems that I gave you last video, or the last time I gave you like a little instructions in the email, let's go back to, again, how they really look like when you see the IR spectrum diagram. So for aldehydes and ketones, okay, usually again, you're going to have a very strong peak here. It's very like dramatic. It comes almost down the entire graph vertically. That usually, and it's going to be only a range between this number, 1600, so it has to be past 1500, around 16 something hundred to 1700 something 1 centimeter for the wavelengths. Okay, so that would be usually your carbon O double bond, right? For carboxylic acids, in addition to having that strong CO double bond, you would have, of course, what we see in quite a few places, your strong broad peak that's pretty fat here, that starts more on the left side of the region, which is representative of your the alcohol, basically that functional group, the OH functional group, hydroxy. Now, for esters, esters would have, of course, again, your strong CO double bond at the same peak range as before. But in addition to that CO double bond, you're going to have a lot of also dramatic, very vertical dropping peaks that comes subsequently, like usually not too far away from your CO double bond. And so those would be your CO single bonds that would be present in the overall ester structure of this molecule. Then you have the amines that will only be in a range between 3,300 to 3,500 1/centimeter. And it has to be a strong peak, okay, in that range. So it can't just be like a little tiny one up here. It's going to be a little bit more down. So somewhere almost halfway through the graph vertically. And that's your, usually it's going to be a terminal nitrogen group at the end of the molecule. Okay, so it's on like either end of the molecule, and it's usually going to be a terminal nitrogen that's attached to, at least a hydrogen. Okay, and that's your typical amine structure. And then the last one is what a lot of students usually confuse with your carboxy or your CO double bond. This one almost could be misunderstood as like a CO double bond, but that would have to be in this range more. This would be shifted more to the left, and it's a lot more skinny of a very dramatic peak compared to your CO double bond. And it's going to be range from 2,200 to 2,260. That's usually where you have a carbon-nitrogen triple bond, and that's a nitrile group. Okay, so that's basically how that looks different from your CO double bond. And don't misunderstand this. Some students misunderstand it for being an amine group too. No, because amine group is in a very specific range here, okay? And it's usually a terminal nitrogen. There's no double or triple bond. Okay, again, the nitrile C triple bond nitrogen in this very, very skinny peak that's usually a little bit past 2000, all right? So with that in mind, let's go to the 5 problems I gave you last time, starting with the first problem. So this is the graph, the IR spectrum you get. You can, of course, use your data table here. if you need. So clearly we have over here your alcohol, okay? So whatever you're going to pick should definitely have an alcohol in there, okay? So neither one of these two have an alcohol, okay? And this one definitely indicates your strong CO double bond, okay? So this one does have the CO double bond, but it has no OH, so we're going to cut that out. This one has a CO double bond as well, but no OH, so we cut that out. So that only leaves room for the very top one, okay? There you go. There's your OH, okay, your hydroxy functional group, and here is your CO double bond. Next. All right, so as we can see here, I don't seem to have an alcohol here, right? As again, the alcohol is in that range, right? So we seem to only have really some carbon hydrogen stretches. So these are your normal CH stretches. This is definitely going to be your CO double bond again. And then of course, followed by subsequently, seems to be a bunch of CO single bonds, right? So take out this one because we don't have an OH. We definitely don't have a nitrogen. So that only leaves room for this one. So I guess this might not be valued here. I don't see CO single bonds. So that's just by process of elimination. They should have had one there because that looks like C single O bonds, but neither one of these would fit either. Maybe it would. Let me see. No, we don't have an OH here. So we can't have an OH. So this is definitely not an acid, right? So, or alcohol. So it's going to be the bottom one, right? Yeah. Though this could be erroneous in your test because we should have had maybe the presence of CO single bonds, but it definitely cannot be an OH and definitely does not have nitrogen. Okay? It definitely doesn't have the nitrile group like I told you earlier, right? Okay. Then the third one, you do not have an alcohol here either. So there's no like fat peak over here on the left. But it seems to me, okay, we don't seem to have that dramatic CO double bond either. So I can rule out this one for sure. So this molecule will definitely have a nitrogen somewhere. Now, if it was a nitrile group, C triple bond nitrogen, you would have a very dramatic peak somewhere over here. Because that's not it. This is a strong peak within that range from 3,300 to 2,400 or whatever. Let's see. This is this one. Yeah, 3,300 to 2,500. That's this range. So it's definitely an NH. Okay, it's a terminal nitrogen. So that's an amine group. So we're going to pick this one. Okay, and these are just normal carbon hydrogen stretches. Again, your carbon hydrogen stretches, okay, are around in that range. So that's your carbon hydrogen stretches. Right? Now, this next part. Okay, so I don't have an alcohol again. No alcohol. I don't have a dramatic, very skinny nitrile group, so take that out. There's no alcohol. So it's going to be one of these two graphs, right? So it seems to me that now we have to pay attention to these other peaks. We definitely still have a CO double bond. So we definitely still have that CO double bond that we've seen many times. Dramatic peak here between 1,500 and 1,700. 1,600 to 1,700 something. And then we're going to look at all these other ones. They seem to be your CO, they seem to be like your CO single bonds. That just looks like a CH stretch. That's not strong enough to be an NH. It's not a strong enough peak to be an NH, okay? Or amines. And definitely we don't have any nitrile, so cut that out. So it's going to be one of these two. And this one does have an oxygen single bond to a carbon. Okay, so I'll pick this one. Yes, so we have to pay attention to these CO single bonds. This is just a CH stretch, a carbon hydrogen stretch, and this is your normal CO double bond. And last but not least, here's another one. Okay, so no alcohol again. Cut that one out for sure. Do we have a nitrogen in here? This I don't think is strong enough, not strong enough of a peak to be, and that nitrogen usually should be a terminal nitrogen, what I mean. So I would rule that one out. So that leaves only this one, because we definitely have, these are your CH stretches, right? So these are your normal carbon hydrogen stretches here. No alcohols here. This one could have been an NH, but it's not strong enough of a peak. This one I have is, you know, normal CO double bond. Yep. So let's see what matches so far. Which one have CO double bond? It's going to have to be one of these two. That will be ruled out for sure because it doesn't even have a CO double bond, right? Which we have right here. So it's going to be one of these two. But because I don't have an alcohol, like in this fat peak here, this will not be it too. So by process of elimination, it should be the top one. There we go. Okay, that's again carbon hydrogen stretches, and this is my CO double bond. All right, so these are the problems that I forgot to finish with you for the IR spectroscopy. And then the next video that's coming right after this is going to be everything you need to know about nuclear magnetic resonance spectroscopy for IB chemistry center level. All right, see you guys again real soon.